Hi everyone, in this video we're going over how to solve mole problems. This will be from your Unit 11 stoichiometry packet on page 2, which looks like this. We're going to do problems 1 and 6 over on the notebook, and you'll want a periodic table to follow along. So down at the bottom of the screen here, we have the diagram, right, this guy here, that shows you the different types of mole conversions that we have done. So we've learned how to convert between moles and grams using molar mass. That's the one from the periodic table. Moles and atoms, molecules, or ions. That's this one here. Now, we're not going to do any of these because when we do stoichiometry, we only switch to units that we can measure, which would be mass and volume. And then volume is for gases, and that's always going to be 22.4 liters. So in our example problems, we're going to have one switching between moles and grams and one switching between moles and volume. So over here on the right side of my screen, I have example problem number 1. And if we look at the problem, we can see that the starting value is in grams. And we're looking for moles. So over here on our diagram, we start with mass, that's what grams is, and we're heading towards moles. So our fraction that we use after the starting value is going to be this one 1 mole over the molar mass. And the molar mass we add up from the periodic table. So I'm going to switch my tab here to periodic table. And our compound here is CO2. So we look at our periodic table, and that means we have 1 carbon, 2 oxygens. So down here, I'm going to do molar mass. So this big M means molar mass. Don't write as big as me, you don't have much space. So molar mass is going to be 1 carbon, so that's going to be the 12.011. Plus 2 times the molar mass of oxygen, 15.999. And that gives us a molar mass of 44. Let me double check. Let's do 0.1. And that's how many grams equal 1 mole. So this will be our conversion factor. We are going to start this like we always do with dimensional analysis. We take the number given in the problem, that's 28 grams. So now that we have the molar mass, we have our conversion factor, we're going to start our work in a second line. So we're going to start with 28 grams. That's our starting value, so we put a placeholder underneath. And as we said, here, our conversion factor is going to be 1 mole over the molar mass in grams. So the 44.01 is going to go on the bottom, and 1 mole will go on the top. The other way we can know this without using the diagram is that grams have to be diagonal. So if we have grams going with this number, that should be on the bottom anyway. So we'll type in 44.01 grams, 1 mole. Grams will cancel out. And we are set up because we're trying to find moles. So we have the right setup there. We just have to do the math. Now, when we have a number in the denominator, that means we're dividing. So that's going to be 28 divided by 44.01. And remembering our sig fig rules, we're going to pick the smallest number. Our starting value has 2. The conversion factor has 4. So we want 2 sig figs in our answer. And if you plug this into the calculator, round it to 2 sig figs, I got 0.64 moles as the answer. So that's it for the gram and mole problems. Now, the only difference if you start with moles, like in problem number 2 on your paper, instead of the molar mass, which was the 44.01 being on the bottom of the fraction, it would be on the top if you're going from moles to grams, and then you'll multiply instead of dividing by the molar mass. But all of these will just be one step. Well, 2 fractions, 1 conversion. So that's it for number 1. We're going to skip down to number 6 because that has the volume problem. So for this one, it says determine the volume in liters occupied by 0.03 moles of a gas at STP. So for gases, if we're going between moles and liters, it's always the same number. Our conversion factor is 22.4 liters equal 1 mole. And that's the same for all of them. So this one, we're starting with moles, and we're trying to find volume, liters. So we're following this arrow here, which means that we have the 22.4 liters on top of 1 mole. But like all of our problems, we're going to start with the number in the problem as our starting value. So 0.030, keep that 0 at the end because that's a sig fig. So we're starting with 2 sig figs. We got a placeholder there. And then to cancel out moles, we want 1 mole at the bottom and the 22.4 liters on the top. Moles will cancel out, and this one you're going to be multiplying. And we will also want 2 sig figs in this answer. This one I didn't do ahead of time. So we got 0.030 times 22.4 in the calculator, and that one gives me 0.67, and that's liters as our final answer. So for these ones, you're always using 22.4. You don't have to use the periodic table at all for numbers 6, 7, 8, and 9, just using this value. For the ones at the top, you will have to use the molar mass. So that is a review of some of the mole conversions that we have done. You'll use that to finish out page 2 as practice. All right, good luck, everyone.